Hello friends, welcome again to the AIM tutorial. So in this video we will learn about what is deep learning. Deep learning is just a modern name of artificial intelligence, ANN with ANN. So then we will have the hands-on practice of artificial neural network, how it is going to define in the different section. Then we will cover up this ANN and its layer, how input, hidden and output layers are going upon this section. And then we will explore activation functions, how sigmoid function is going to calculate, how this is going to explain. Then I'll cover the hands-on practice on building neural network on the XOR and the input output layer upon these values. So we can have this iteration also. Alright, so first I'll explain that what is the deep learning. Deep learning is just a modern name for artificial learning with many layers. So what's deep in deep learning though? It's basically due to structure of artificial intelligence, ANN. Alright, so ANN consists of some n numbers of layers. I am having the layers here, and then I can have the next layer also, and then this will move to the next layer. So it will cover up the how does deep learning offer from machine learning. What is the success of the machine learning lies in the right set of features. Alright, so next we are having the neural network, which is the basic signal biological neuron, and it can have axon and synapses. So it can be multiplied with the particular inputs. X1, X2, X3 are the inputs, and W1, W2, W3 are the weights respectively. So then we can have the certain output over there. Z is the output, and this is the multiplication of this one, and this is the bias. We can have the bias of the line particular on the X and Y axis. So I can have the output of these inputs, and the respective bias will go with the sum, and then we can have the output with activation function. I'll cover up this activation function within a minute. So we are having, as of now, we are having two inputs here and three hidden layers and one output layer. So this output layer can have binary classification. It may output as 1, it may generate as 0. So you can have the binary classification out of this neural network. So this neural network will cover the hidden, output and different sections. So we are having this sigmoid function, 10h and 10 function. So what is this sigmoid function? This is defined by this this function. This is the sigmoid function, 1 over 1 plus e raised to power x, and the curve is defined by this one, and 0.5 is the middle value, which is having this threshold value, midpoint of this. So anything beyond this 0.1 will be classified as 1, this 1 class, and anything beyond this 0.5 will be classified as class 0. So that is the significance of sigmoid. And one more thing is specific here in this function. If you provide anything in this function, it will give just nearby value nearby 1 or O. So as the node probability lies between 0 and 1, since the sigmoid function squashes the values between O and 1, it used to for predicting the probability of output. Similarly, we are having 10h function. So 10h function is defined by this one, and then rectify linear function. This is just O in the one direction, then ReLU function over there, and then leaky ReLU again, exponential unit, and then switch function also. The switch function is recently introduced activation function by Google. So we can have that function 2x row beta x sub. So we can reparameterize these switch function and express it as this values. So one more thing is here, that is softmax function. We can have this softmax function, the input variable softmax function, and this output. So softmax function is basically generalized of the sigmoid function. It is usually applied to the final layer of the network, and while performing multi-class classification task, it gives the probability of each class for being in output, and thus sum of the values will equal to 1. So this is the defined function over there. So then we will cover up the hands-off practice of this input layer. Here we are having building neural network from scratch, and then input and output and XOR function will work over there. So O1 will go with the input and layer, any output layer, that is output should be 1 over there. So we will have 4 or 5 hidden layers. This is the input layer and the output layers. So I'll just open my collab file, and then I'll just show how this code is working upon any collab library. So in order to run my IPYNB file, I'll use Google Colab. So by default it support TensorFlow, because I will use TensorFlow, and I'm having that file also, and that supporting file also in the Google Colab. So I'll just upload this file. I'll give in the comment section in the description box that all these files will be uploaded in my GitHub account very soon. So here I'm having Python code. So first I'm having building neural network from the neural, and it is just uploading on the Google Colab site. And by default building neural network is putting concept so far. So I'm just importing all the necessaries libraries, packages, and you need to change your unrecognized runtime Python 2, which is defaulting to Python 3. So I'm going to change this Python 3, and you are not supposed to change this hardware accelerator, because this is required when you are using more complex programs like n number of images, 1000 and 10,000 images, and then you are using these hardware accelerators. So as of now we are writing very small piece of code, so we are not required that high level of hardware accelerator. So I'm using this accelerator, this libraries only, and then I'll prepare the data for XOR. Okay, so here I'm going to explain this piece of code. So I had the table O, then 1. Alright, again I'll write this code according to this. Okay, so here I'm having 0 1, then 1 0, then 1 1, then 0 0. So with respect to O1 I will have the output, so I will have input over there, and this is the output there. Alright, so I am going to define over there. So this is the one output, and one output there, and here I am having 1, here I am having 1, I'm sorry, here I am having 0, here I am having O. So same inputs having 0, unlike inputs I am having 1. So in the same way it's going to work over there. It is defining the inputs and outputs. Now I am having 2 inputs, 5 hidden layers, and 1 output layer. So as you can see over here, I'm having 5 hidden layers, 2 inputs and 1 outputs. I'm setting that variables over there. So these variables are defined as per my neural network and going to scratch over the network. I'll use these variables in the upcoming code. So now I'm defined the weights and bias. So this is the random function, and it is going to new input and number hidden. So as per number hidden, in between in between number inputs, that is 2 and number hidden, so it is built-in method random number, and it will define the random numbers in between 2 and 5 and 0 between 1 and hidden. So that would be the bias randomly. So let me, if I print these values, let's see what is the value w x h. I'm going to print over here. Alright, so this is 1 2 3 4 1 2 3 4 5 1 2 3 4 5. Alright, so why I'm having 10 numbers over there? Because 1 2 3 4 5 with respect to one input, 1 2 3 4 5 with respect to second inputs, and all these inputs are mapping towards the hidden layers nodes. So these are having 10 numbers with respect to 10 edges. Now I'm going to print print my bias bh. So that is O. So 5 bias, that is zeros, I am going to create over there. So 1 to 5, that is 5 bias will be printed over there. So similarly I'll do for the y. So this is for the x and hidden to output layers. So I'm going to run these code again, these variables again, why. Okay, so this time I'm having 1 2 3 4 5. So why 5 over here? Because 1 2 3 4 5 edges are going to merge into the output layers. So I'm having 5 outputs over there. Then I'm going to define my sigmoid function, which is very pretty much defined, and then I'm going to sigmoid derivatives, that is the sigmoid function again, and then I'm going to forward propagation with respect to xh and xy. So this is np dot, means this is the dot product between x and wxh. So what is the x over here? I'm having x over here, that is the input part. And what is the wxh here? That is the weight with respect to inputs, and then zeros. Then I applied this sigmoid function to z1, then z2, that is the a1 to vh second weights plus by, then y hat is the sigmoid of z2. What is the sigmoid function over there? That is this function. So this function you can write over there like 1 upon 1 plus e raised to power minus z. So this function can be written as this derivative function, this simple function. And then we are having derivative which we will use in the backward propagation. So the delta 2 is multiplied by minus y hat, that is the error of this function, that is the this one output of the first layer. Then I am using sigmoid derivative, that is the minimize function. Then I'll use the y hat to dot product of this function, and then delta y to the dot product of, and I'll do the same process to define the back propagation. Alright, so now I will define the cost function, which is 0.5 multiply sum of this one raised to power this one. That is, I can write like summation of y minus y bar whole square divided by 2, because two inputs are there. Alright, how many inputs are there? Two inputs are there, so I will divide by 2. So this is the cost function. I'll define this cost function. Now I'll define this learning rate and number of training iteration, which is 5000. I'll define in this way, and let's train the network. I'll train the network for input iterations and forward propagation, that is defined over there, and then I'll perform backward propagation and calculate the gradients, and then update the weights, excess and djy and cost function, and then append c again in each iteration. So then I'll plot the cost function for the each value. I'll have this cost function for the training iteration. So it was very high earlier and then introduced for rest of the, as you can notice, the loss decreases over the training iteration. Thus we have to learn how to build a neural network from the scratch. In the next chapter we will learn one of the popularly used deep learning libraries called TensorFlow. Thank you.